Hello, in this video of our series on machine learning using R, I want to talk about dimensionality reduction using tSNE. So first, let's just go over a few key points about tSNE, which stands for T-Distributed Stochastic Neighbor Embedding. So tSNE nonlinearly reduces high-dimensional data to 2D or 3D for visualization, excelling at revealing clusters. It converts distances to probability distributions, minimizing the KL divergence between high-dimension and low-dimension spaces. It uses student t-distribution to avoid crowding, spreading points evenly, and it's computationally intensive, preserves the local structure but not global distances. It is sensitive to hyperparameters like perplexity, requiring toning. In R, if you want to do tSNE analysis, you need a package called Rtsne. So here I have R codes here for install this package. And also we need a ggplot2 for visualization. So let me load in these two packages and set a random seed, create a data set with 4 clusters, sample size 1,000, and dimension is 50. So we have cluster 1, cluster 2, cluster 3, cluster 4. They're all Gaussian clusters. Okay. And we combine these clusters into one data set, and we give them labels for all names and column names. Okay, so a key step for performing the tSNE analysis is to select the perplexity parameter. So here I want to show you the method using the PCA for preprocessing plus KL divergence selection. Okay. First, let's run a PCA on the original data after scale it. And also we just extract the first 30 principal components. We get to the range for the perspective, that's a perplexity, and then create a vector to store the KL divergence, and then just running through the loop to calculate the divergence. So it's going to take a little bit of time. There's some warning messages we're going to ignore. Let's continue to do some cleaning to make them of equal lengths, and then we can plot out this select optimal perplexity. So it's the KL divergence plotted against the perplexity here. So we actually reached the maximum amount. So we look at the 50 in this artificial data set. So in the real data set you're analyzing, this may not be the case, but this is approach for you to actually select an optimal perplexity value. Okay. All right, now let me show you how to perform the tSNE analysis using optimal parameters. So here you can see it is the syntax. You call the function Rtsne, you put on the PCA data. So you need to be careful you're not using the raw data set, you're using the PCA data, and you wanted to do 2-dimensional embedding. So you use the best per, that's 50, you select it as the perplexity parameter, theta equal to 0.5. You specify PCA, you're not going to do PCA again. And maximum iteration 1,000, and check duplicates go to false, and then verbose is true. Yeah, so it runs pretty fast. Then you can record the coordinates and then label them and then give them the column name, and then you can visualize the clusters. Okay. So you can see in our artificial data set, The separation is pretty clear. We got 4 clusters. And there's, I think over there, there's 1 or 2 data points kind of in the middle of 2 clusters. Those may be difficult to classify, but overall, this is pretty clean analysis. Okay. All right. This is a pretty straightforward, simple demonstration of how to perform an tSNE analysis using R. Hope you like it. Thanks for watching.